Hi everyone. Thank you, Serhan, for having us. So my name is Cüneyt. For non-Turkish speakers, it's pronounced like the month June and number 8. So it's Cüneyt, but I'm born in June 15th. So I represent Zero Density for CEE, Russia, Turkey, and CIS countries. And we would like to give you a brief explanation about Zero Density overall, who we are, what we do. And then we will have a live demo video in Izmir, and I hope you enjoy it. We would like to have an interactive demo here, so if you have any questions, please feel free to stop us and let us know. Zero Density has been founded in 2014 by 3 or 4 partners who are coming from broadcasting and gaming industry. And they had a vision. The vision was to have the graphics of gaming industry in broadcasting, because as you know, they're beautiful, and you're never able to see as beautiful graphics in broadcasting and TV channels. And in 2014, they have sit and have rewritten the codes of Unreal Engine, which is by far the biggest and strongest compositing and rendering gaming engine in the world, which belongs to Epic Games. And after 2 years of work, hard work, in 2016, Zero Density has launched a product in NAB. And since that day, it has been the global hit. So we had a destructive product which has been working on 500 engines all around the world. So the main market that we have is obviously broadcasting networks. So if you think about CNN US, Weather Channel, BBC, NHK Japan, CCTV China, Channel 1 Russia, TRT Turkey, any of them, Brazil, Global, Star India, they're all using Zero Density product. And we do, in our ecosystem, we do have software part and hardware part. Okay, in software part, we do have Reality Editor, Reality Engine, Reality Keyer, and Reality Hub. We'll get in deep in a couple of minutes with that. But also we have provided the new hardware platform called Reality Engine Ampere, and the Traxxas, which is the first stereoscopic talent tracking system in the world, which has won the best product of the year in NAB last month. These are the technologies that we have established and we have shown to the world, and we're constantly growing. So who we are based in Izmir. We are around 100 engineers, and we are constantly growing. And if you guys have any background in Unreal Engine or you're engineers, please approach after this, because we really need such kind of talents. Other than that, in today's demo, we would like to show you guys the Virtual Studio, how we do the rendering, compositing, and the keying parts. We will also show you the Traxxas, the tracking system. As I explained to you a minute ago, it has no markers or any beacons on your hand. This is, again, the new in the technology. And after that, we'll have the hardware platform, Reality Engine Ampere. The beauty of our product is, this technology of Virtual Studio is not new. It has been around for many, many years, more than 30 years, 40 years actually. But some of you guys, if you are, let's say, old enough, have some concerns about this technology, because you've never received such a realism before Zero Density actually. And now when you see our product, you will see the contact shadow, reflections, and all the realistic features by the power of our keyers. And all these keyers that I'm talking about is a software base, so you do not actually use any hardware, information hardware. And my colleagues in Izmir will get in details on this, but our keyer is image-based keyer. And as you know, in chroma keying technology, you usually use the differences between green color. But in our way, we key pixel by pixel. This way, you won't have any problem to key a green talent or any transparent object. Okay? Anything should I mention before we start is, as I said, please, I know some of you are not aware of Unreal Engine. Some of you mainly in production part of this market. This could be like French to you guys, but it's okay. Your part is French to me as well. So please feel free and ask whatever you have, okay? So Ali, can you hear us over there? Ali? Ali, can you hear us?
Yes, we can. Yes, we can.
All right. Microphone is on you guys. You can go ahead and start.
I have a talkback. So I will mute you, then I will start. Okay?
Sure. Go ahead.
Okay. Hello, everyone. It's me, Ali from Zero Density. I will share my screen fully, so you will see in a big picture, and we will get a better quality on stream. And then we will start with the presentation, and we will go ahead and we will take a tour on our studio, and we will start with the Visual Studio application. So let's get started. So today I'm going to talk about Reality Ecosystem. What we have in the Reality Ecosystem, we have Reality Engine, Reality Editor, Reality Key, and Reality. This is our agenda for today, roughly. We will talk about Reality Ecosystem, we will talk about live operations and production controls. We also talk about green screen compositing, AR compositing, and talent tracking with Traxxas Talent S. So what is Reality Ecosystem? Reality Ecosystem basically is our software suite. So on top of the software suite, we have Reality App. Reality App is our control application, which lets you control multiple engines with multiple users in a web-based environment. Reality App gives you the ecosystem connectivity, workflow integration, and live operation. Reality Editor is our editor for creating your world. For example, if you want to do a virtual studio, you will design your world in Reality Editor. If you want to do the AR, if you want to do the overlay graphics, if you want to do XR production, you will design your elements inside the Reality Editor, and this is our creative application. And on the right side, we have Reality Engine. Reality Engine is our engine, and which handles video, compositing, and rendering. And also, we do internal keying within our engine. So we have Reality here, and this is our keyer built in our system, and this is an image-based keyer, working fully on the GPU, and it's also tracking aware. A few notes about Reality keyer, you will see the quality of Reality keyer in later on, but it also has support for 4K, HDR, and RAW data coming directly from the cameras itself. So today, what we're gonna use? We're gonna use a crane with a mechanical tracking system. We have an equipment crane. We will use a broadcast camera, which will be shooting at Ultra HD resolution 60 FPS, and we are using a Grass Valley RDX86 model, and we have a zoom lens from Canon. We are using a cyclorama with lights, and we also making R&D of a paint, so we are using our own paint. As for the hardware, we have a few hardware selections which you can select. So at the top, as you can see, we have HPZ4G4. This is our legacy hardware, and on this hardware, you can find more specifications and the features in our documentation page. And on the bottom side, we have Reality Engine Ampere, which are the orange workstations. And as you can see on the right-hand side of the presentation, you can see the details of the Reality Engine Ampere. So Reality Engine Ampere is our machine, which we are building in-house. And the idea of having an in-house built-in machine is, first, this is a turnkey solution, so you can gather hardware and software directly from one vendor. And also this machine specs is really high and really up to recent and up to spec. So what we have an A6000 for the GPU, which is the latest and the fastest GPU from NVIDIA. We are supporting Aja Core with cards, Core with series of cards, and you can add up to 2 cards at the same time. So you can have 2 Core with 88 or 1 Core with 88 or 1 Core with 4412G. So it's depending on your configuration. And also we have 65 gigabytes of RAM, 1 terabyte of SSD, and blah blah. And as you can see, this is a pretty powerful machine. And one more thing about Reality Engine Ampere is when we are developing a new version of Reality, we are testing on this platform. That means that we are ensuring we will have no problems within this system. And also, if you have a problem within your visual set, you can directly send your visual set with us. And as we have the same hardware, so we can be kind of eliminating the hardware kind of a problem of this setup. So next, another hardware which is Traxxas Talent S. Traxxas Talent S is a stereoscopic AI-based talent tracking system. The benefit of having this kind of system is you have no variables, so your talent can go inside the tracking area and will get tracked without attaching something onto his body. So there is no dongles, no markers, and nothing on your talents, and it uses AI to track your talents. So this is end of my presentation, and I will start with the overview of Reality Hub, and then we will go and start with the Visual Studio. So let's get started. Reality Hub is a modular application like this. As you can see on the bottom. Sorry about that. I will reshare my screen. Let's get started. So this is Reality Hub. As you can see here, Reality Hub works on a web browser, and it's a modular application. On the bottom part, you can see that we are only having the engines, and there is all black. So what we can do is we have modules, and we can create the modules and from right here. So this is playout module. Playout module basically is for your operators. In a live environment, what you do is you simply create your templates. After your creation of the templates, you just select your templates, drag and drop. I'm just doing it randomly, and create your rundown. So that way you are creating the flow of the show. And from the pressing buttons, you are creating and you are running your show from the playout tab. This is for the operators, and I will also show you how you create templates. This is Newsroom tab. Newsroom tab is an integration with MOS protocol. In the news channels from around the world, they are using an NRCS system, Newsroom Channeling System. And there is a protocol called MOS to have a communication with third-party applications. So Reality Hub with the MOS protocol can communicate with iNews, for example, Octopus, Dalet, EMPS, like these kind of third-party applications. That way you can get the data directly from these applications into the Reality Hub automatically. What we have NodeGraph and Actions tab. NodeGraph and Actions tab is our Operations tab. So what we are doing is we are creating a NodeGraph, and from this NodeGraph, we are getting our outputs on live, and we can also use this tab to create our forms, create our templates, and we also have an action, so you can create your basic animations within the NodeGraph and Actions tab. And lastly, we have the Launcher tab. Launcher tab is basically automation system. For example, right now this engine is running. So this is my engine that I'm using on this demonstration. This is my project, and this is my artgraph. Artgraph is the file which you save your NodeGraph. When you save your NodeGraph, it will become an artgraph. And when you feel those, when you hit start, the engine will start automatically. And the good thing of the NodeGraph is you can have multiple engines. For example, you can refer to that multiple engines into the multiple cameras. For example, if you have 5 cameras or 4 cameras, you will use 4 engines basically, and you will select these projects. That way you can run the same show with multiple cameras with one click of a button. So this is how the launcher works. So right now, let's jump into the Visual Studio. Let's show you the output, and then we will show you the overview of the stuff, and then we will go back and forth with Reality Hub and Reality Engine. So we will see, and we will experience more out of our product. So now you are seeing the direct STI output from our engine into your screen. So this is the direct STI output from our engine, and now I will talk about reality here. So before we talk about reality here, I will do a transition and you will see we are inside a green studio. This is our studio, this is our cyclorama, and we have a puppet mannequin inside the cyclorama, and we are running a camera attached from a crane. So let's get started with reality here. Reality here is image-based here. And as you can see of the detail, when we are zooming fully in, you will see that reality here is image-based here. It is keying pixel by pixel. What is the benefit of this? The benefit is you can even key hair detail, every strand of the hair. And as you can see in here, in this shot, this is a direct feed from the camera itself. And this is the result of the reality here. So we can keep every hair detail and we can keep this and we can fully utilize the power of reality here. And another hand is, what we are doing is we are always doing a 3D compositing. What gives us is depth of field. For example, when we do our key, we are not doing a layer-based A to B compositing. We are compositing this talent, this key talent, inside the 3D space. Right now, what's happening is my cameraman pulls the focus back and forth, just from the farther plane to the in front of the plane. So whenever the cameraman pulls the focus in front, your talent will get focused. And when the cameraman pulls the focus on the farther plane, far away, you will see that the virtual graphics will get focused. We can do it automatically because we are doing a 3D compositing in our system. You can tilt down and let's see the edges of our talent, and let's show you one more thing. As you can see in here, we have a talent, and our talent is plastic and it's also reflective. This is a very worst case scenario within gears. But as you can see, you may also see some spill inside of the hand of our talent. So reality here has built-in spill suppression algorithm. So it helps you to key the talent. Also, it helps you to remove the green spillage onto your talent, and it keeps the shininess and the colors of your talent. We can tilt down and lastly show how we key our shadows. So I have said earlier, reality key is an image-based key. That means that you can really key the shadows that has been generated by real-world lights into your scene, and we can extract that shadows and use into our composition. So these shadows that you are seeing is real shadows that has been generated by real-world lights on the ground. Okay, thank you. We can have a master shot. And as you can see, this is the quality of reality here. So what we have, what are the main other benefits of having a virtual environment is, first, you are living inside a game engine. So what I mean by that is you can create video walls, you can create animations, you can create everything that you can imagine, and this is all running live. So this is Weather Channel doing 24/7 weather broadcast in US, and they are running a whole year. So with a click of a button, they can make it rain, or with a click of a button, they can make it go on to night, or clear skies, or overcast, or a cloud skies. They are just click of a button, and I am using only one engine. So they are running whole season. So they have also seasons like this. And also, they even change the position, they even change the whole environment while the system is running. So in real time, you can change your environment as well. So this is the benefit of having a node-based compositor and living inside the gaming engine. So what I'm gonna do is I'm gonna switch into this. This is like a picture-in-picture mode. You will see the output on the right-hand side, and I will talk about and show you a few things about our system left-hand side. So I am changing the position of the studio, like here with the click of a button. I am changing the seasons, like here with a click of a button. And also I am changing the weather like this. So as you can see, we are inside the node-based environment, and in this node-based environment, it's sometimes hard to find these. Where is my node? Where is my node? So what we need to do is you can simply create a UI, user interface for this. So let's do this. On the right hand side, we have form builder. I am just creating a new form, and I will call this new form as the weather channel demo. Let's save this. So I can simply get these, drag and drop. Let's have the night as well. Save it. And when I go onto my playout, I can drag and drop, and I can go in between this. So your operator will use this tab, and you can simply let the operator to control your show real time. Also, you can also use this one. This just animates in the video walls up and up and down. This, let me just drag this, and let's get this one, and let's also get this one. Saving it, and when we go into the playout, now I can up my video walls and drop my video walls, and I am controlling this with the buttons from here. So the idea is pretty simple. You just find your node, find your functions, and drag and drop to create your UI really easily. But you are not limited with functions. You can also create whatever you want. You can also create the properties as well. So let's drag and drop these. Or if you want, you can even drag and drop the transform. So this system gives you the idea and ability to control all of your node graph within a UI with a drag and drop functions. I didn't write any single line of code, and I have just created my own UI. So the system is very flexible. And in the form builder, lastly, I want to mention this. You can also get external data from a third-party application or a web service. So you can get data from a URL, or you can execute a JavaScript function. You can get the data directly from a web API, or you can get it from a SQL server, or you can get it from a CSV, or you can get it from an Excel file. So the system works on a web server, and it is really flexible to get your data, fetch your data, and use it on live production. So let's talk about the node graph and what is node graph and what we have it inside of the node graph. So what I did, I have created this pipeline for you, and this pipeline is basically a template. In this template, we have used composite cyclorama here. So let's explain what we are using to create this kind of photorealistic output at the end. So in the input side, we are using with Asia. Asia is our STI video input board, and we are, in this case, we are using COVID-44. And as you can see, we are getting a quad channel input. So we are getting a 4 times HD video, and we are combining these videos to create a quad channel link, quad channel video. And we have a tracking data. Can you just move the camera just to showcase the tracking data? And as you can see, when the camera moves, you can also do zoom in, zoom out, change the focus. And as you can see, when the camera moves, zooms in, zooms out, change the focus, this data is changing because we are getting the camera signal from the camera, and we are getting the tracking data from the crane itself. That way, we can create this composition. What you need the camera inputs, and you need the tracking data. And this is all happening real time. So let's talk about how we do our keying. So we are utilizing a cyclorama to create a mask of our real-world environment. And with this cyclorama, we are doing our keying. As you can see right now, our talent inside the 3D procedural mesh. And from this mesh, we are creating this environment. So what you do, you just measure your cyclorama, and you just put the numbers in there to create your mesh. So this mesh is tracked, so whenever you move the camera, it always stays in the place. For example, if I want to add the size just a little bit, you will see that my cyclorama goes higher or lower, bigger or smaller. If you have a 3D model of your cyclorama, or if you have a 3D model of your environment, you can simply use your 3D model inside the cyclorama, so you don't have to adjust it at all. What we're gonna do is, we will show you how easy to create a clean plate to start keying in Reality Engine. I will do a transition, and as you can see, right now we are seeing an off thing. So what I did is I have just removed my key data, removed like clean plate to remove the all keying data from the engine. What we need to do is we need to empty our cyclorama, and we will take a picture from the camera. That way we will start keying. So right now we are emptying our cyclorama, and what I will do is I will press this button. I have just pressed this button, and as you can see, we have just started keying pixel by pixel. You can go in and put the girl in, and as you can see, we are there. So we are taking a picture, and we are keying pixel by pixel from that picture. So let me show you the passes of our keyer to see it a little bit more. So this is the direct SDI video input from our camera. This is the clean plate. This is the photograph we have taken just 30 seconds ago. And we are subtracting from this photograph to this running video image, so that way whatever left is our key talent, our key environment. Combined soft matte is a pass for translucent objects, edge detail, hair detail, and as you can see, shadows on the ground. Core matte is for opaque objects and is for representing the body of our talent in this pass. Also, we have a spill suppression algorithm, so we also have a different and dedicated spill matte pass as well to remove the spill and add back the colors on this process. Final matte is our combination matte of these three passes. This is with the color, and this is our composition. So reality keyer is image-based keyer. The idea of it is it keys pixel by pixel. So you have the final detail, and you don't have to have the perfect cyclorama. As you can see in here, we have a little cyclorama, but our colors of our cyclorama, it's not perfect. Some of areas are darker. In these cases, some of areas are brighter, and still we can get a perfect result because our system is image-based keyer, so it gives you the flexibility to run this kind of stuff. What we have after the keyer, we have the projection. Projection is our method of compositing in a 3D space. So I bring a dummy cube, and I will explain you how the projection works. So as you can see, we have a red wall and we have a blue wall. So red wall means I'm projecting my talent onto this wall. Whenever I move this cube just behind of the talent, behind of the red wall, that means that my cube will be rendered behind of our talent. And if I move this cube just in front, that means that my cube will be rendered in front. And this is not a magical cube. I can just create another cube. And I can also move this cube just behind, like this. And as you can see, now I have two cubes, and they are rendered at the correct depth. This is how we adjust, and this is how we composite in a 3D space. Everything is happening in a 3D space, so you don't have to have a mask to move where is in front, where is the front, where is the background renderer, and we are doing everything in a 3D space. So this is how we composition. And in here, I want to show you one more thing. Reality Engine is a node-based engine, and which is also running real time. And we are doing a 3D compositing. The benefit of this kind of setup is, for example, I want to do a color correction. I'm just like connecting the pipes. Now I can color correct my background like this. Like this. But I want to do a color correction into the keyer. What I need to do? I need to do this. Now I can do directly this, and I can do a color correction into the keyer. Like this. Okay, I'm happy with that, but it's too dark for me. So I need to brighten this whole picture. So I can do the color correction after the composition. So this, and now I can do a color correction. Like this. So this is how we can do the setup. So the setup is pretty flexible. So you can do add detail, add blur, add color correction. We have two-way of color correction and color correction three-way. If you are really into the color correction, we have like this kind of color correction. And if you really know Nuke and Flame, and you can refer to that, this is the real-time version of a Nuke or Flame. So you can do really composition inside our system. Lastly, you can also do that. You are not limited with the camera, or you are not limited with the talent itself. You can color correction whatever you want, and you can add the effects in whatever you want. For example, I have a running video. Let's run these video walls up. Let's play the video. And let's play this video. One of the video I have connected directly, which is in the middle. And on the right-hand side, I am adding the color correction. So let's brighten these up. So as you can see, now in the middle is normal, and on the right is bright. So I can put these in here. So as you can see, now I have created three videos, and all these three videos is color corrected from a single node. So this is how the system works, and this is how we do our system. This is how we do our composition. So this is pretty simple. You just connect the nodes, and you see the output in real time. And this is Reality Engine and Reality Hub within a overview. If you have any questions, you can ask your questions, and then we will run into another composition, which will be AR, and then we want to go back into the Green Studio. We want to show you the talent tracking system as well. If you have any questions, I would like to have your questions for a few minutes. So,
thank you a lot. By the way, can you hear us?
Any questions?
Any questions? Can you hear us? Hello, can you hear us?
Yes, we can. Yes, we can.
Okay, thank you a lot for your presentation. We really appreciate it. We will start taking some questions. Anyone has any question?
Ali, I think we have a question. Do you have a water bottle over there to show the transparency effect?
No, we don't. No, we don't find one.
At the meantime, maybe Manaf can find one, and we can take another question, because they're asking to say it.
Yeah. We tell it. Can you go in? Okay, we find one.
Okay, thank you very much. This really looks nice. You've used a model that is static. How does it do with movement? How does it render movement?
Yeah.
Especially as you said,
we
hair.
are just putting
hair is always very tricky.
It doesn't make any difference actually, but now we have another talent inside, and he can move. But do you have anyone with hair?
No, it's like Saturday for us. But it's also a good thing because it have a lot of spill. Can you just zoom in all the way and focus?
Ali, biraz zoom'un kalitesini arttırabilir misin? Biz projeksiyonda çalışıyoruz. Çok.
Okay, let me just give you a full screen so you can see it better. As you can see, this is working with a water bottle. Anyway, we didn't do any setup. We can make it better, but this is a water bottle, and we can also key the water bottle while we have inside the water. Okay, can you just drop the water bottle, and can you just look at in an angle? Yeah, like this. A little bit more. No, just look at this side. This side. Yeah, keep it there. Can you just zoom in to glasses? and do the focus. And as you can see, we have a guy with the glasses. It's like also transparent, and we have no problem with the glasses as well. You can see the hair detail on the beard, maybe. Yeah, thank you.
To use Aja capture cards only or any others? No.
Right now, we are only working with Aja. We are working with Corvette 4488 and 4412G. But after this year IBC, we will have a new product will be released. It will give you more flexibility, I can say that, both for the SDI and both for the IP SMTP 2110. But right now, for today, we are only working with Aja Corvette series.
I just want to ask something about color correction in the video.
Yes.
As we know, the highlights and the shadows are very realistic because it's independent with the original scene. But if we color grading the model and the green screen, can we making individual effect like color grading the background separately, or it will be affecting on the same highlights and same shadows?
So in here, if you do color correcting before the composition, you can color correct your background, or you can color correct your talent individually. But if you do it after the composition, it will be effect on the same. So for the color correction, I can give you one thing. What we are doing is, when you are getting the SDI video, we are linearizing the gamma. And you are getting SDI video from the 8-bit or 10-bit with the HDR. But when you are doing the color correction, we are working with 16-bit textures. So you will have more range to do a color correction. We are not doing a color correction with the 8-bits, because that way you will lose the data and you will lose the value. So when we are doing this, we are getting this SDI and creating a linearized gamma. With this gamma space, we can do the color correction with the correct math. And when we are doing the output, we are also reconverting the color space that you want to have. That will be Rec 709, or that will be Rec 2020, or you can use a different gamma curve for HDR or SDR. Hope just explains this technicality a little bit.
If we had the two models in the same position, their shadows will be interrupted or separately? Just I want to ask this.
Their shadows, if they are keyings, their shadow will be the same. Alan, can you go in? But what you can do is you can shoot your talent with a two different camera with a different part of the green, and you can compose it at the same time. That way you can have control over your shadows of the talent 1 or talent 2. Can you just tilt them and show the shadows? Yeah. Right now they are coming from the same keyer, so they will have the same color correcting or same tone. And right now you are seeing with the white pants and also with the white shoes, which is a really hard thing with the conventional type of gears. Yeah. Thank you, Alan. Okay. Okay.
What is ray tracing at this point? Maybe as a gaming.
Yeah. Yeah.
What is the advantage?
So I'm just stopping this engine, and I will run this engine. So it is same engine, different project. We will run Traxxas. So let's start. And we will see the Traxxas with maybe a real one, real human. Okay. Okay. Yeah. Menab, just lock the camera, give us a wide shot, and just go. Maybe that will be better. So we are preparing the set. Let's get off the screen. Yeah, that's good. And now I will talk about Traxxas. First, we will talk about the output, what we can do. And we will also show you the UI of the Traxxas, how we're tracking our talent, and how we're doing our composition, and how to configure the Traxxas as well. So I will share my screen. So you will see the outputs in a full screen. So I just mute you just to not get to talk back, and let's talk about Traxxas. So Traxxas is a talent tracking system, and it is actually, in this case, what we are having is we are doing a ray trace set. So this is the same set with the ray trace, so we have a more reflecting ground, and on this set what we can also do is you are seeing the reflections real time. This is a ray trace reflections, and we are tracking our talent. So in the older scene, we don't have a talent tracking system, so we are doing the projection manually. But in this one, our projection and depth projection of our talent done real time. That means that my talent can easily walk around the 3D object. Meanwhile, he is walking around the 3D object, he will always have ray trace reflections under his feet. And if we introduce a light source, and from this light source, we can also have a follower light, which can create shadows real time. And from this follower light, as you can see, we have introduced a colored follower light. So the color of this light also have effect of the keys, like key after the color tone after the key. So these color also affect the keyed talent color. And this keyed color, this follower light is getting the tracking data, so it follows our talent perfectly. And also this one is a virtual thing. So you can also add a DMX light, which is a real light with like a DMX light at like globos or light hats, spotlights. With these DMX lights, you can make the with the help of the talent tracking data, you can really match the colors both on the virtual world and both on the real world, and you can really create an events with this type of DMX lights, and our engine also supports DMX lighting, so you can really do a seamless lighting inside the virtual world and into your talent as well. But this one is the virtual representation of this. This one is just a virtual light, and the color of the virtual lights also affect our talent. So this part, this will be our talent without the effect. So this is a direct keyer from output from the keyer. So there is no effect on our talent, but you may want to need that effect because when you have these dramatic lights, you need to have it affected on your talent as well. So this is one thing. I want to show you one more thing. Can you just move over that area just for the trigger up the video mouse? Yeah, like this. So we have added a trigger onto our body of our talent virtually. So whenever he goes that place, the video walls pop up automatically. Whenever he goes on the other side, the video walls pop down automatically because we are knowing the position of our talent, so he can trigger events automatically based on the position itself. Like in this case. Can you also come just a little bit in front on this corner to just show, okay, This is good. And you can also see some reflections on the ground, just on the 3D Traxxas logo from the ray trace reflections, because what we are doing is we are creating reflections real time and we are doing a 3D compositing. So you can have some reflections on the ground with the plexiglass into the 3D world. But you cannot have a 3D reflections on a 3D object inside a virtual studio with plexiglass. So we are doing a 3D compositing, and this is the output of 3D compositing. I want to show you one last thing too before I go to another thing. So I want to show the frame. As you can see, can you just walk around, move around? As you can see, when the talent moves, this frame moves with the talent. What we are doing is we are actually getting the talent tracking data and attaching this talent tracking data into this frame. So whenever talent moves, this frame moves with him. So that way we can always composite him into the 3D space into the correct depth. This is how this works. Okay, you can stand still, and I want to show you one more thing. When you are knowing the depth of the position and when you are living inside the virtual world, what you can also do is you can also do a flying animation. For example, with a click of a button, I need to go into the configuration mode. You can also do flyaways like this. So what's happening right now is you still have your talent. Your talent lives inside this. You still key your talent. You still composite your talent. Your talent lives inside the 3D world. But what you are doing is you are using a virtual camera. And from that virtual camera, you are doing this composition. This. So I want to go in a picture-in-picture mode, and I will show you. I have used this to fly away. Like this. You can also move your talent in the 3D space real time like this. And I'm just pressing the button to fly back like this. To demonstrate this thing better, what I'm going to do is I will move my talent into the camera and we will put a puppet, and because I want to show you one more thing. While we are doing this kind of composition and while we are doing a flying, we are actually offsetting our camera. We are not removing the camera. We are not removing the camera track itself. So when the camera moves, when I'm doing the fly, that means that you are doing a virtual fly animation, and also still even if from this height, you have the camera tracking itself. So this is my cameraman moves, and from these moves we are creating this. So you can extend your jib to create these kind of shots from this virtual fly animation itself. We call it hybrid fly because we are offsetting our talent tracking, we are offsetting our camera tracking data, and we are not removing our camera tracking data. What I'm gonna do is I will fly back. I want my GPR operator to go back, and I will fly back, and when the camera goes really close, my GPR operator will also get close. That way you will have a smoother operation. So I'm flying back, not this one, let's wait for the other one. And I will do the flyback again, that way he can really do the setup. Let's do the flyback, and when the camera comes closer, he will move his jib, that way we will have a smooth operation. Like this. So that way you will have like a seamless and moving whole one-shot setups like this. So in this scenario, what we have showed you, we have showed you ray trace reflections, we have showed you shadows, which are virtual shadows, we have showed you color affecting the talent and also color following the position of the talent. We have showed you hybrid fly cam with additionally enhanced with the camera tracking, so we are not removing the camera tracking. we have showed you how easy a talent can move around 3D objects in the correct depth without using anything. And we also show you the triggering the 3D talents, triggering animations based off the talent position. So we have showed more things inside the virtual environment because we have a talent tracking data. This is the third data we are getting. We are getting the camera data, camera video. We are doing key compositing. We are getting a tracking, so we are knowing the position of the camera, so we can do the composition at the correct position. And with the talent tracking data, we can also do the composition of talent in the correct depth and each frame real time. So what I'm gonna do is I will switch into another scene, not another scene with another screen. So I want to show you the Traxxas UI itself, which is our trackers UI. So what I will do is I will go in, I will swap the SDI signal. Okay, now what I'm gonna do is I will show you the full screen, so you will see the Traxxas output, and we will see the UI of the Traxxas, and I will explain what's Traxxas. Okay, as you can see, you are now seeing the UI of Traxxas, and we have a talent inside on this world. What we have in here is we have the Traxxas attached into here, onto the ceiling. You can see that we have a camera and also we have a processing unit, and this system is a hardware system. So it has the hardware, software, it comes as a bundle, so it's a tracking device itself. So, and this is the UI of the Traxxas. As you can see, we have a talent and we are tracking the position of the talent in real time. So what I'm going to explain is the camera knows his tilt. Also the camera knows his roll. So whatever angle did you install of your Traxxas, it doesn't matter for us. You can install your Traxxas with whatever angle you want. So you are just installing your Traxxas. After your installation, you just give it the power, and it does require the power and with the Ethernet cable to send the tracking data. And also what we're gonna do to create a composition, and what we're gonna do the calibration is pretty simple. You just need to give your heights, which is in centimeters. You just need to give your pan offset, which is also in degrees, and you just need to give your 0 point. And let's change the height and let's see what's happening. Let's make it 100. As you can see now, the height of the talent, which is the circular icon of the 0, is in the wrong place. So I'm just putting in the right place, and basically what you need is you just measure from the ground to the camera body itself in centimeters. And that's it. That's what you only thing that you need to give. And then you just do the right click on the picture and put your 0 point onto the 0 point of your camera tracking itself. So my camera tracking 0 point is here, and I put the 0 point is here with the right click. And I can adjust the coordinate system itself like this. So I do it like this to adjust my X and Y and Z values. So what I did, I have just adjust my 0 point. I have gave the height, and I have adjusted my coordinate system itself, and I'm done. So this is how you calibrate, and this is how you install the Traxxas. So install it physically, and you just give your 0 point, give your height, and give the pan offsets. So this is the setup that you need to do. What I can do is I can also add some more area to track our talent. So I just adjusted the more area, so my talent can go in a bigger place. He can go wider, so I keep track of my talent. And the idea of having an adjustability of a talent tracking area is really simple. So you may have a shooting crew which may be behind or around your talent. And if you really want to track your talent, what you need is you can adjust your area of your talent movement, and you can adjust your area of the talent tracking. That way, you may not you may not want to track your cameraman, or you may not want to track your shooting crew or any other people. So the adjustability, it gives you a great flexibility on your scene. And also, whatever a person just out of the tracking area, the tracking data will stop. Can you just go out? And whoever person just enters in the area, it will start tracking. So you don't have to put anything on your talent. You can have different people to get track as well. If you have time, can you go in, Ellen? Just go in for 30 seconds. Just go in and out. Yeah. And as you can see now, right now we have a new talent, and you will see that now my talent will get tracked. Can you also go in right next to him? Okay, stay there. And the first one enters in that area will get tracked. As you can see, the other guy is grayed out. Menaf, stay there, and Ellen, you can go out. And whenever the main guy goes out, the other guy will get tracked, because it looks for the talent, first talent that just enters in that area. So as you can see, right now we can track both of the people at the same time, or multiple people at the same time. But right now we are only sending the one guy of the position of the one guy who enters in the area first. Right now it is a 1.0 version, but the next version we would like to add multiple people tracking within the Traxxas itself. So it will come with a software update. So the setup is pretty simple. Just give your height, give your pan, give your 0 point, adjust your tracking area, and it tracks the talent automatically. It also tracks humanoid objects, like a mannequin as well. So you just give your IP and the port, and it can send the tracking data within the multiple engines. And also you select your production FPS. So you may run 25, 22, 30, 60, 50. So you are getting tracking data from that resolution. That way you will have the smooth tracking data, and you will have the smooth camera, so you have the smooth production. So you can have a different output of different FPS outputs of a talent tracking data. Tracking data sends as a 3Ds. 3D is an open protocol, so you may not only use this talent tracking data with Reality Engine, you can also use it with Unreal Engine, or you can also use it with other providers. So this is Traxxas talent test, and one last thing that I want to show. Can you just turn backwards? Just turn back. Yeah, turn your backwards. Go inside. Yeah, thank you. And as you can see, if your talent still is turned backwards, we can still track our talent. And can you just also just do some jogging, do fast movements to just show? As you can see, if the guy moves faster, we can still track our talent, because we are also calculating the speed, and we are also getting the body data and the head data at the same time. So if something like a big desk or box in front of our talent, we can still track our body of our position of our talent, because we are tracking the body and the head at the same time. The next update will have multiple people tracking, and after that update we plan to have a skeletal tracking as well. This is on our roadmap, and this is the Traxxas talent test. You can go on, thank you. You can put the mannequin in, and we can have some questions if you guys have any of them. Any questions about the system? I'll add ask to unmute, so you can unmute and ask if ask your questions if any, or you can also use the chat box. Yes, we can. Automatize the focus. Yes. Yes, you can do it. I can not show you the whole process, but I can give you a hint. If let's save the all questions, and I will show you this at the end. Any more questions? Yeah. Okay, good question. So the idea of this, we are working with broadcaster 24/7, and they want to run dedicated missions. So what we recommend is one camera for one engine. It doesn't mean that our engine doesn't work with multiple cameras. We have a customer that uses 2 cameras, or we also have a customer uses 3 cameras in same engine. That means that 3 camera input, 3 tracking input, 3 keyer, 3 virtual camera renderer, and 3 outputs at the same time from one engine. Technically speaking, you can use multiple cameras and multiple outputs at the same time. 3 outputs. 3 input, 3 keyer, 3 render, 3 outputs from one engine. It is technically possible. We don't recommend it officially, but you can use 2 cameras to render, 2 keyer, 2 output if you are running HD resolution. There is no problem with that. As with Ultra HD, so yeah, we recommend using 1 camera. Yes.
But
yes.
they have 3, what's the name? Compositor.
Yes.
One engine.
They are using the same
they-
engine. The same engine.
Hmm.
And they are running it 3 separate composition paths in our engine. So 3
different-
inputs. Yes. 3 camera, 3 trackers, 1 engine hardware. So we are getting 3 SDI. We use 3 separate keys. We use 3 different camera renders inside our engine, and we will give out 3 outputs as an SDI.
Can we capture with NDI only, or only use SDI? Or what is the?
We can use SDI.
No, NDI.
And we can also use NDI.
Yeah.
We don't recommend NDI on keying. If you want to do a keying on NDI signal, it's not good because NDI uses CPU, and loses the it's like a compressed data, so it won't give you the best quality if you do the keying. But you can do NDI. You can still use NDI to get like an external sources, like a video wall or like a Skype connection. You can do it, and it works really fine. Our engine doesn't ship with the NDI plugin itself, but you can install the NDI plugin, or also our technical support team help you to install the NDI plugin, and it's working without any problem. The idea of not giving the NDI support directly because NDI is our competitors' software or protocol, so we cannot ship it with the NDI plugin, but it's free to use. So customers or user, or even us, we are using NDI in our day-to-day demonstrations or day-to-day setup.
Thank you.
Any more questions?
Actually, excuse me, I have a question. What's the future of the? Okay, this is a great technology for live shows, for live TVs, I think. But what's the future of this technology? Have you ever tested it for example, commercial production, for filmmaking? Is it going to replace real locations anytime soon? Thank you.
So this is a good question. So what we can do with an engine, you can do the virtual studios, you can do the AR scene, or you can run a virtual video walls as well. You are not limited with the green screen as well. Within our solution, you can run a video wall, So you can have a video wall graphics, or you can do like off-axis compositing to have like a Mandarin kind of setup. Or you can use our Keyer, and you can use a Visual Studio, or you can use it for AR purposes. Right now, for the commercials on China, Shanghai Istanbul, which is our partner, they are using our engine for commercials. We have some installation in Japan too. They are doing some short films and films. And we have some customers, we cannot give the name. In US, they are doing film production within our engine. So there are more things coming within the IBC. IBC is the trade show which will happen this year around September, October. And we will have more features and more products which will support these kind of workflows, including cinema. Right now, it's 90% of our customers is broadcasters, yes, but as for the emerging of the 4K, HDR, and new features, we are also having new customers on production houses in all around the globe to make film and commercial kind of more high-level productions.
Also, this is very important if you're trying to shoot a scene in Taksim Square, let's say. You need to get the permission, you need to get the cameras, but with our solution, you can easily do that. And especially we have customers in Japan that they do this kind of shooting in Tokyo, in the street. So this is the advantage that you can have. Ali, I think we have one last question from the beginning, and you can answer that, and we can do the AR, and then we can take the final questions.
The autofocus, right?
Yeah, correct.
Okay, let me share my screen, and I will show you not the full setup, but explanation of it real quick. Okay, when we are going here. So, what you can do is, right now we are getting the 3D data. And this is X and Y. And from this X and Y, you can create the position. And right now I'm just creating the position, breaking the transform to follow the cloud, follower light. And you are just getting this data real time. So that means that you also have the camera tracking. And this camera tracking has the focal distance. Right now it's on 300 centimeters. So you can, inside our engine, you can really calculate how far our talent. That way you can pull your focus and zoom from this data. But what you need to get the output from our engine, and you need to run your motors on your lens itself. You can do the virtual one automatically without doing anything, because the virtual one is simply, so like what I can do is, we have the post-process node. What I can do, I can break the track. I can make a track. I can get these zoom and focus as an output. Can connect these. And I can connect these in here. So in the post-process nodes, we have the depth of field, and depth of field is comes from the focal distance. So we can get this focal distance as a separate output, modify it with the position of our talent, and put it in our engine, and we can do this setup automatically inside our virtual world. But you need to get this data and send it into your camera, or if you have a motorized lens, you need to send this data into your lens to also do the focus automatically without utilizing a cameraman. So I believe that's explained this setup just a little bit.
Thank you very much. Thank you very much.
In the virtual, yeah, it's easy. So what I will do right now is I will run an AR scene and we will talk about AR composition. So let me launch this one. Right now I have launched my AR scene and we will have this in a second. So let's get started with an AR in our engine.
Excuse me, in the meanwhile, we have a new
What I'm
question
gonna
to
do
take,
is I will
please.
talk about AR in here.
Can you hear
right,
us?
Right now, as you can see, we have a light source, we have an AR piano.
Excuse me, in the meanwhile, we have
Yep.
a new question. Tahir, you can, okay.
Hello,
Okay.
can you hear me?
Yes, yes, he can hear.
Yes, I
Okay,
can.
I have one question here. Can I use this tracking data with another 3D software?
Yes, because this is a 3D data.
Yes, so it can be exported, for example, for Cinema 4D, After Effects, those kind of. I mean,
Yeah. Yes, you can use it.
uh,
3D data is an open protocol. So that means that you can get the data and utilize it for later on.
even with the multi-camera
But
in the scene.
yes,
But
for
I-
the camera track, we are using it.
But
You-
we have to export it one by one.
Yeah.
I mean, it's not gonna be like compiled data for the three.
Yes,
cameras.
you need to record one by one. Yes.
Thank you very much.
If you want to do like a post-process kind of setup, what you can do is you can get our key outputs separately without any render. You can get our composition, and you need to record your tracking data, your camera tracking data, and you can also utilize our engine because our engine runs with the Genlock signal. So when you match these data in 3D, like Cinema 4D or Nuke or Flame to make a post-production, yes, you can also do this kind of setup. But you need to you need to use a camera tracking system which has a possibility to record. Some system has a recordings camera record possibility out of the box. Some of them sells as an extra, like Moses type, Trackman. These have usually they have camera tracking recording feature already. So let's talk about the AR scene. And as you can see, you are seeing AR piano with shadows, ambient occlusion, and you are seeing some reflections. So what I'm going to show you today is I want to talk to you about the reflections over the piano itself. Can you just go in front of the light source and just show the reflections? Yeah. As you can see right now, you are seeing reflections from the light source. Can you just go over there? Yeah. And we have a talent, and this talent just goes over in front of the light, and as you can see now, he is blocking the light. And also you can see his reflections real time, because what we are doing is we are also doing a 3D composition, so that way we can have real-time reflections from the video itself into the AR, so real to virtual reflections onto your AR objects. What you can do also is you can have some reflections on the ground on this area, which will be also the real to virtual. As you can see, while he is moving, you can see his reflections as well onto the ground itself. In this scenario, we have two types of reflections, real to virtual on the ground, and also we have an object, which is like an AR object, so you can see also the virtual to virtual reflections itself onto the ground as well. So I will explain how we get the reflections, but I want to also talk about the shadows, and I want to also talk about the ambient occlusion. So as you can see on the top of the picture, you see two light sources, and actually we have put the two virtual light sources at the same position. That way we can create these shadows on the ground. You can adjust the intensity of the shadows like this. But the idea of this is actually you want to match with the real shadow source. Like this way you can really match the amount of shadows that you want to create from this scenario. And you want to add these light sources at the same position of your real world light sources. That way you will also matching this shadows positioning as well. The type of light that you want to use is affects how sharp or how smooth shadows that you want to get. In this case, I have used the spotlight, and they give me the hard edge shadows. But if you can use like a rectangular light to have like a more smooth edged shadows as well. So the systems also support this kind of setup. And lastly, we have ambient occlusion. Some of the trained eyes can see the ambient occlusion right away, but when I remove it, you will see that right now I just removed the ambient occlusion, so piano looks like it's flying over the ground. But when you add the ambient occlusion, now you will see that my ambient occlusion affects and help me to make it sit on the ground much better way. So what we have reflections, we have shadows, we have ambient occlusions, and you can have this real-time composition of AR in this scene. What I'm gonna do is I will switch onto the picture-in-picture mode, and I will explain about our AR a little bit more. So what we have here is we have less nodes because we don't use cyclorama, we don't use keyer. So we have the camera input, we have the camera tracking, and we have the projection. That's it. So this is much simpler as the configuration of the nodes and as for the composition of our scene. So I want to go and I want to explain how we are creating the reflections. I will go into the channel 6 and I will give you a full screen and you will see what we are doing. So our 3D object is staying in the place. And when we're moving our camera, can you just move the camera, zoom in, zoom out? Our camera moves. And with the help of the tracking data, we are only showing this composition in the correct perspective. So that way, you can see that right now when the camera moves, it moves. And that way, if we really have a reflecting light source, you will see that our reflections works in real time. So this is how we do our composition. We are projecting our video inside the 3D world. We have a 3D spherical HDRI map to get the lighting on our scene, the basic lighting of our piano. And we are running the video to create the reflections and also help of the lighting. And also we have created field lights to light up our talent and create the shadows on the ground. If we turn back into channel 1, our final composition, you will see that our final composition is there. So because we are looking at the right perspective, and we are doing a 3D composition, and you can get this AR composition real time. And one more thing, when you are doing transition, you will see that we are not removing the pixel, we are not affecting the pixels, so you can start without AR and you can add the AR whenever you add in. So we are only affecting the pixels when the AR object is there, and the rest is not changing at all. So we are not affecting the color space basically. So I will go in here and I will show you how we get the reflections on the ground. So in this projection, we have this, and as you can see, we have 3 objects. So let me remove this. Let's also remove this as well. And as you can see, I have a blue object, and this is a projection cube. When I add this actor, now it will become reflective, and I have 2 puddles, water puddles. And when I add this, it will become also reflective, because these are individual objects within our scene. But when you connect this, it will become reflective, because in our projection method, we have a material, and this material, if I make this material fully rough, you will see no reflection. And when I do this material fully zero roughness, you will see a lot of reflection. And we are getting the video, the clear video, so that way you can have the reflections on the ground. And as this is a fully zero roughness material, it will reflect whatever happens into this 3D environment. This is how we can get reflections on the ground. And we are using only one camera to create reflections. That means that this is more performant. The general way of doing the reflections on the AR show is you create your second camera, invert the camera, blur the camera. Maybe that way you can get the reflections on the ground, or you will do the masking on the reflections, but that way you are rendering the second camera. It is costing more to your GPU render. It is costing more budget related into your render itself. But in this case, we are only using one camera to create the reflections. And as you can see, we are outputting the shadows, render itself, reflection, and blue. And we are combining these into here, into the composite passes. So I want to run a multi-viewer to show you the full screen, and you will see it better. So as you can see on the channel 1, this is our AR. On the channel 2, this is our clean pass. On the channel 3, this is our bloom pass. On the channel 4, this is our reflection pass. On the channel 5, this is our ambient occlusion and shadow pass. So we are using, we are getting everything from the camera. That means that we are actually modified the source code of our new engine to create this. So that way you can have more performance in our AR scene, and you can go for more resolution, like 4K, and for the video input and render. That way you can have a better AR and better storytelling with the help of the shadows, reflections, and ambient occlusions. And what you run inside an AR, the scene, is important, and how you match the video camera and the AR, the colors itself, is also important in this case. So in this scenario, we are really dark, moody environment, because our camera made to shoot with the green studio, so our camera settings is more like a closed iris kind of a scenario. So that way when we turn our camera back, it's much darker. But if you are outside, or if you make your camera setup fully for the AR scenes, so you will have really better results than us. This demonstration is for showing you the possibilities and showing you the main features and main setup of our scene. Lastly, I want to show you how we create and how we make the shadows on the ground alongside with ambient occlusion. Can we just move the camera backwards and tilt down just a little bit? A little bit more, thank you. So what we have here, and we have two light sources. Let's have it like this. So we have two spotlights, and whenever I move the spotlight's position, you will see that the position of the camera, the position of the shadow changes, because these shadows running real time. And as you can see, we have a channel. It says green, and this one says blue. That means that we have two channels. From these two channels, we are creating the shadow channels. So I can go on this and create how dark or how light my shadows will be. And also I have a mask, which is a 3D based mask. So from this mask, I can say that I want to create the ambient occlusion only on that area, but not on the other side. So that way, as you can see on the right hand side of the statue, which is on top of our reflection plane, that has no ambient occlusion. And the piano itself has some ambient occlusion. If I remove this, it will look like this. And if I add this, you will see it's like this. And we are using a Reality Shadows ambient occlusion pass, which is also built in our engine. And lastly, I have used a template, which is composite augmented shadow template itself. We also have track talents, cycloramic here. We also have tutorials for different kind of workflows. So our system also gives you templates for free, so you can learn it and you can tweak it, and you can know it how to use our system better. So this is just also an overview of our AR scene, live AR scene scenario. So if you have any questions, I would like to answer your questions about AR as well. Any questions?
Thank you a lot for the AR
Sorry, I just
presentation.
muted.
Okay, I'm
You can
unmuting
unmute
myself.
itself. Yeah.
You can hear me now, right?
Yes, I can
Thank you
hear
a lot for your presentation, your AR presentation. I don't know if anyone has any question about this AR, but I have a general question about the whole system, another question. Do you think, from a technical side of view or point of view, do you think this is going to be a more user-friendly system anytime soon, like if it lives for the next 10 years or so? I mean, is it the, I don't want to say it, but excuse me, I don't have any another expression. Is it the new chroma key user-friendly technology in like the next decade or something? Thank you.
Can you repeat that stuff? There is a lot of noise around.
What was the last thing you heard? My questions are a bit...
Ali, I
Last two
think the
sentences.
confusing part is the R graphs. So Abdu is asking, is it possible for this kind of solutions to be more user-friendly? Actually, I think you showed that at the beginning. The guys who are doing the R graph parts are different engineers and the operators are different. So maybe you should elaborate on that a little bit more.
Okay. So the idea of it is, for example, you are using like node-based compositors, or you are using like DaVinci Resolves, or different programs, even out of going for a node-based approach. So they were layer-based, but now they are going for node-based approach, because when you are living in node-based environments, you are not limited. You have more control over your scene. So you can really control your scene better. To make this scene or make this setup easier, what we are doing is, we have an academy, so you can like LED walls. Also, what we are doing is we constantly do partner trainings. But also we are doing is we created Reality Hub. Before the Reality Hub is a web-based application, and you just have drag and drop control for your operators. So when you are shooting there, you just press the buttons and create your composition. This is what we made Reality Hub for. In the shooting day, you just press the buttons. But for the preparation, you just need to use the node graph, because what this kind of system does is actually gets your time of your post-production. If you are using these kind of systems, you don't have to do the post-production that much. For example, when you're doing 100% post-production, it will become to like 20% or 10%, because you are doing a lot of things before the post-production, and you are seeing what you are shooting real time. What is the benefit? Benefit is for your like, you can really turn your like monitor and show to your actor what he's doing, and you can also see the composition earlier. So it also helps with your previs, and it helps to have more time to finish things up. So it will also cut your time of your post-production phase. What it introduces is pre-production. Now with this kind of setup, you need to design your scene, you need to design your world earlier. So the time of the post-production goes into the pre-production, so the post is pre-production in these kind of systems. But the advantage is, if you design it earlier, you can change the scene, you can change the environment, you can change the colors, you can move the object's position, and you are doing rendering in the real time, so you can really know what you are shooting. This is the main benefit. And for the node-based application, yes, everybody goes for the node-based application, and we will keep the node graph, but we always have this drag and drop user interface, and we are also in the next versions with Reality 1.3, we have also better drag and drop UI with different buttons and different kind of things, and we also have support. We're also giving support for external keyboards. Right now we have external keyboard support, but it's limited, but we also adding external keyboards for the color corrector type of keyboards. We are in our roadmap, so we'll also support these, so that way you can use your existing hardware with the system. That way you don't have to get lost into the node graph itself. So in the next years, we will support more hardware for the cinematic people, like the color correcting boards like this, to have easier to use for the other kind of producers and other kind of productions, let's say. So things will get easier for the next years for these kind of programs, but node-based compositing will not gonna go anywhere, because it's much easier to do a complex scene in a node-based environment than in a layer-based environment. Because if you do layer-based, you need to do everything in a one page, and it's goes. If you are doing it simple things, that's fine. But if you are going like a final master shot, it goes a little bit odd when you have a lot of things into the scenario, into a shot, into a scenario. Yeah. Maybe it just gives you an overview and answer your questions just a little bit. Okay, any more questions?
Yes, you really did. Thank you a lot. I'm sorry, I was just... Thank you a lot.
Yeah, no worries.
Any more? Anyone has any question? I believe we don't have... Mr. Sarhan, do you have any question?
Yeah, the reason of, first of all, we're using Unreal Engine, first of all, because they're a huge company and they're creating games with the revenues over than $2 billion a year, okay? And there are more than 12 million users of Unreal Engines. So whenever you need some kind of content, these guys are available and you can use them. Also, there are sets on the Unreal market that you can use, which are free of charge or very price-wise very competitive. For 50 euros, you can buy a prison. That it's very cheap, actually. Yes, we understand your concerns that for some of us it looks like space, space stuff, but everything we got used to it. And as Ali said, we will have more hardware implemented, so guys like you can use this easily. And it's coming very soon. And as the community, Ali, I think I'll have a couple of minutes here. We do have a community version, which is on the website, which is free of charge. You can download and use it. And everything, all the licenses are available. There's only one little watermark, which will say zero density. And you can utilize only one engine, which is one camera. Like, and you can start playing with it, learn it. And you can also log into our academy, which is recently launched, and learn how to operate the system. Okay? So I think this demo has been more than 1.5 hours. Thank you very much, Ali, and thank you, Mena, for everything. I'll be here for another 1 hour, I think. So if you have any non-technical questions, which are more financial-wise, and usually this is what comes, how much this system costs, I'm here to explain you and give you that kind of questions as well, okay? So if you don't have any other questions to Ali, we can give a 5-minute break, and then I can take those questions. What do you mean? Maybe I should have mentioned that at the beginning. This zero density is native base. By saying it's native, it is not a plugin. So you don't need to use Unreal in the system. It's zero density. Code has been rewritten for broadcasting purposes. So you have nothing to do with Unreal. The only thing that you have to wait is, right now Unreal has Unreal 5, version 5. And after 3 months of their new release, we have our own release. But again, in a couple of months, we'll have some new releases that will disturb the market, and it's coming very soon. That I cannot tell you what's going to happen soon. Okay? But you can use either those sets in zero density. So 5 minutes break. Thank you, Ali.
Thank you, guys. Thank you. I believe it's the end of the show.